Project 1.1, Kirchhoff's voltage law. Circuit 1 contains a 9-volt power source, a 1 kiloohm resistor, a 470 ohm resistor, and a 2.2 kiloohm resistor. This circuit can be used to prove Kirchhoff's voltage law by measuring all the voltage drops and seeing if the sum equals 0. This is a circuit diagram representing circuit 1. In KVL, the voltage rise, which is the voltage provided from the battery, counts as voltage drop. This means that the voltage used up in the circuit must be equal to the voltage provided from the battery. Using a DMM, we can measure the voltage rise and voltage drops in a circuit. The voltage rise measures 8.68 volts. The voltage drop from the 1 kiloohm resistor measures 2.35 volts. The voltage drop from the 470 measures 1.108 volts, and the voltage drop from the 2.2 kiloohm resistor measures 5.2 volts. The sum of these three voltage drops is 8.658, and if we subtract that from the measured voltage source, there's only 0.022 volts of unaccounted voltage, which is due to the DMM measurements being rounded and aren't actually 100% precise. This is circuit 2. Circuit 2 contains a 9-volt power source, a diode, a 470 ohm resistor, and a blue LED, 5mm LED. This is a circuit diagram for circuit 2. As you can see, there's a 9-volt power source. This power source is split between the diode, the LED, and the resistor. Now the diode and the LED both have a set voltage that they will take up, and then whatever is left will be taken by the 470 ohm resistor. In this circuit, the voltage rise measures 8.51 volts. The diode has a voltage drop of 0.707 volts. The 470 ohm resistor has a voltage drop of 4.696 volts, and the LED has a voltage drop of 2.821 volts. Now, if you add up the sum of these voltage drops, you get 8.488 volts. And if you subtract that from the voltage source of 8.51, that leaves 0.032 volts of unaccounted voltage, which is due to the DMM measurements being rounded and not 100% precise. This is circuit 3. It consists of a 5mm blue LED, a 1 kiloohm resistor, and a 470 ohm resistor. This is a circuit diagram of circuit 3. As you can see, there's a 1 blue LED. This blue LED will take up a set voltage, and then the remaining voltage will be divided amongst the two resistors. The amount of voltage that R1 takes up is dependent on the ratio of R1 divided by the total resistance in the circuit, which is 1,470 ohms, and then multiplied by the voltage source. In this case, the voltage source minus the voltage taken up by the blue LED. In circuit 3, the resistance total is measured at 8.58 volts. The blue LED's voltage drop is measured at 2.69 volts, meaning that the voltage presented to the two resistors is 5.89 volts. If we measure the voltage drop from the 1K ohm resistor, we get roughly 3.9, which equals 1,000 over the resistance total of 1,470 times the voltage being presented to it, which is 5.89.